God eftermiddag, eller god formiddag er det vel. I am delighted to be here today. As a Danish native, I've been in this location quite a few times, usually though on the floor with some fancy rock star on the stage. So I get to smile on stage today. We will touch on a more technology-close topic. We will talk about the Flutter project and our attempt at building a new way of building apps for multiple platforms, including both iOS and Android. We started this project quite a few years back, and one of the very initial things we did is we kind of surveyed what was happening in the industry. You're probably all really familiar with the native approaches. You can get the regular Android SDK from Google. You can get the iOS SDK from Apple. If you get those, you can build super high-quality apps. There are hundreds of thousands of these in the app stores. They're highly performant. They sit on super native architectures that have been refined for almost decades by now. It is not without issues, though. You're probably also intimately aware to the fact that you need to staff 2 teams to build 2 apps, different APIs, different languages, different tools. And it's not just the double investment of having to build all your code twice. It's also the fact that you need to keep 2 things aligned. Your customers expect a single feature set. There are plenty of groups or families with mixed OS households. And they all expect the same from you as a company. So you need to keep your features aligned, you need to keep your schedules aligned, and just make sure the whole thing just kind of seems like it came from a single company. You also, of course, need to make sure that the brand you have is represented in an equal way on both sides. So there's been a lot of demand for trying to single source things more. We looked at a number of approaches. It's great for development speed. It's great for portability because you can write some of the code just once. But in some cases, you do suffer in terms of performance. The demands on mobile apps are rising all the time. And there's many more animations, much more custom layout. And it's just hard to get that combination of fantastic performance and a real native look and feel using most of these approaches. So we kind of went back to the drawing board and said, what if we try and challenge some of the assumptions and try and do some things in some different ways? Can we achieve different results? And we make quite a few different choices. Some of them will seem odd at first. Who knows? Some of them may seem odd in years from now. But I'll try and walk you through some of those decisions, why we made them, what we're trying to achieve, and what the implications are. So hopefully, if nothing else, you'll get an understanding of why we've done what we've done and to what end. I will talk about this through the 3 pillars we usually use to represent the product. We really want to make you productive. We understand that the marketplace is just at such an insane speed, so it is critical that you can develop apps faster. It is essential to any startup or any enterprise that you can keep up with the speed of the market. It is also essential that you can create a really expressive UI that is a natural extension of the brand values that you're trying to communicate. And of course, customers are used to whatever they're used to. So whatever's on their iOS or Android phones today, there are lots of assumptions about what it has to be. So we need to be mindful and respectful of those. Let's start with development. We started out by challenging what the UI representation should be. Most frameworks use some variation of XML. We thought we should try something else. So we use code for everything. There's no distinction between layout and business logic. It's all just code. This has a bunch of implications. It means that you get to stay in a single abstraction. You don't need to kind of jump from one representation to the other. It means you get to do all the things you've learned in coding. If you need to do conditionals or looping in your UI, you do that using code. If you need to refactor, you do that using code. If you need to componentize or reuse across apps or whatever, it's all just code. It does look a little odd at first, I have to admit. So let's kind of walk through what this code actually does. First of all, everything is a widget. A button is a widget. The text string inside the button is also a widget that's composed by the button. The whole app is a widget. Each and every screen in the app is a widget. It's all just widgets. So here's the way you declare a widget is you extend either our stateless widget or our stateful widget, depending on whether you're holding state. And then you implement a build method. So in this case, our build method is going to create a material app, and we're creating a scaffold, which is just a way of building out the raw skeleton. And there's an app bar at the top, which inside it again composes a text with a string inside it. And that's it. So that's really how it breaks down. So you should notice that it's all based on composition. There's very little inheritance here. It's mostly on the two classes I mentioned already. Everything else is composition. Of course, now, one of the issues with code is that after you write your code, you need to run your code to see what your code does. I guess there might be a few in the room that are clever enough to actually understand what their code does, but I certainly don't. So you need to compile it. It takes a long time. And again, it's not so much the fact that it takes time, a few minutes. It breaks your rhythm. You're in the middle of doing something. You have a purpose. You make a change. You want to see the effect of that change. So we cannot do a traditional compile cycle here, because that wouldn't work with this type of UI representation we have here. This is why traditional IDEs give you UI designers, because it's a way of short-circuiting the whole compilation process and a way of previewing your XML artifact. We don't have an XML artifact, we have code, so we could try and make compilation faster maybe. It turns out that's what we did. So what we do is at development time, when you run your app, we run everything in a virtual machine. Virtual machines are really good at loading in new changes. So whenever you change a line of code, we just tell the VM to reload this definition. Your app is running all the time, so you don't stop your app and restart it. You just shove over the new definition of whatever code you changed, and you see that effect. Then we added a bunch of UI inspection, because we found instead of trying to map from whatever your code representation is to what's happening on the screen, it's typically very useful to do the opposite, which is to run this big code base that you have no idea what it's doing, look at the output, the result, and then pinpoint something in the result and ask the environment what code is producing this result, so you can alter that code to change the result. So it's this combination of UI inspection and the ability to quickly iterate on the code, which we call hot reload, that we believe is actually one of the ways we can offer more productivity. Let's try and take a look at this in practice, and I hope the demo gods will be with me here. All right, I am in Android Studio. We are running against an Android device right now. I have opened up one of our little sample apps called Shrine, and I want you to imagine that I just got this out from source control, and someone's complaining that they can't read the label on that brown button there. And I have very little idea what this code does. That's how my coding usually is. So I'll take the UI inspector here and take this little target here, and I'll just click this button, and it will show me the whole widget hierarchy. It will also pre-select here in the code what's happening. Let's just close that, and we are in here in a raise button with a piece of text that has a text style, and it looks like the style here. Let me just deselect that element so you can easily see what's going on. You can see the text style is brown, and the button is brown, so that's a pretty trivial issue. We'll just change that to white. I'm going to save now. Whenever I save, we do that hot reload, and you can see at the bottom it said it reloaded 5 out of 439 libraries. So whatever I changed just got redefined and got reloaded into the running virtual machine, which is rendering that app in the emulator, and it re-rendered that OK label in white. We can do all kinds of changes. There's a radius here that's describing the rounded, or I guess the straight corners on it. So we can make this bigger, and we can save it again, and you should see it gets even more jagged, I guess. But I guess it's all code, so it's not like we can only do UI tweaks. We can try and go to the next screen. So here's a list of elements, and I can click an element, and it goes in the shopping cart. And you could imagine I wanted to try and highlight items that have a low price. So again, I have no idea what's actually rendering this price here. But I will open up my UI inspector, and I will select a price, which is there. and go back. And it looks like there's a text widget here, and it has a style. And I'm just going to go to declaration on that style. And the style is up here. And now we want to do something conditional, right? If the price is below a certain threshold, we want to use a different style. And again, I said earlier, if it's all code, right? So how do you do conditionals in code? You can do an if statement. So if the product's price is less than 50, let's get some brackets. We will change the style. It's all immutable in Flutter, so the way I changed it here is I cannot mutate the style I already created, but I can copy it. So we will copy that and set a new color. Colors.red, semicolon, save, and you should see this thing here should be changed to red. It's a little small. Let me make that bigger for you. Let's make the font size 18, and it should be bigger. And again, because it's all code, it means that there's no limits. It's not like we only do certain UI tweaks, right? We can change all the code. So how about we change the statement here, the logical condition, to 75. We should see sunglasses go on sale. We can even try and see if we can break the system here. So here's a sized box that controls the size of each of those images. Let's try and misspell width and hot reload that. This didn't happen, actually. There's an issue at the bottom saying we didn't do a hot reload because there's analysis issues in your code. We're using a fully typed language here, so we know that there's no property called WITH. But there are other things you cannot do statically, of course, such as let's do a negative width here. We'll try and save that, and it looks like I may have broken the app. Because the problem is there's a bunch of constraints on these widgets, and they're not compatible with the fact that a sized box is now negative 120 in height. But the app is still running, right? I mean, I can go to the shopping cart. I can go back. It's not broken. It just doesn't render some part of it because that part doesn't respect the constraints. So I can go back here, and I can fix that bug, and you're back and running, and I can add this to my shopping cart, and everything's good. I personally find this very satisfying because I make a lot of mistakes when I write code. And the fact that I can just stay in the flow, I can iterate. If it breaks, I just fix it. And it's just like step by step, this very gradual refinement of the UI. All right. All right. I was just using Android Studio. You can use Android Studio. You can use it against both Android emulators and iOS simulators, which is a little weird, I admit, in the beginning. You can also, if you prefer, use a more lightweight editor. We use the open source editor VS Code. We've written a bunch of plugins for that, and I will give a demo of that a bit later. But should you have any other preference, VI, Emacs, whatnot, we also created very rich terminal tools. So what you're seeing here, that little snippet, is you can create an app. You can look at all the running devices. You can even spin out emulators. You can run your app. And you can also do that hot reload. You just have to hit the R button in the terminal. And then combine that with any editor of your preference. So we really try and give you a lot of flexibility here instead of cornering you into just a single IDE. It turns out now that mobile apps are about more than just UI. So we have, like most other multi-platform systems, we have a plugin system where the UI can talk to the native OS host. We use that to plumb out a bunch of common APIs on both Android and iOS. We also partnered with the Firebase team and added out great support for most of their services. But if you want to, you can just add your own of these little adapters, these packages. And there's a package repository that you can upload these to if you want to share them with others. Or you can pull down packages yourself that others have written. And there's been more than 800 of these Flutter-specific packages contributed over the past year, just since we launched in beta back in February. All right. So we've got the basics down of coding now. We can describe our UI. We have a very untraditional editing cycle. But we have to create some UI that's a little bit more aspiring than the simple examples that I had. Another thing we did here before we started is we looked at what types of apps were winning awards. there's a selection of 6 different apps here that have won some type of design award. The montage shows each of these apps on both Android and iOS, side by side. When I look at these, there are 2 things that I see. First of all, they look remarkably similar across Android and iOS. There's some symbol variations in terms of typically icons or font sizes, maybe font faces. But the core of the design is actually the same for most of these. They don't look like the inbox apps either. There's nothing here that looks like the settings screen of Android or the settings screen of iOS or their email apps that come bundled. They look a lot more unique. They have this very expressive design that, again, is meant to be an extension of the brand. I'm pretty sure if you go to their home pages, you will see the same design language. If you go to their letterhead, you'll probably see the same design language. It's just a natural extension of whatever they do. These are the types of designs we wanted to support. So it has some implications, again, because it doesn't look quite like what you get with inbox widgets. This, by the way, is not a new thing. When the web started, we had these very similar-looking buttons all over the place. I believe at some point Google.com looked like that, and then they changed to a different button style because a new button definition came out. But that's not really what web apps look like anymore. They look more like the stuff on the right, where you customize the heck out of it with a gazillion lines of CSS, right? So it's so custom now. Everything is custom because that is the way you communicate a brand. These are the types of apps we want to allow you to create, something that really stands out in the marketplace. And one of our mantras has been that we don't want to say no to any designers. It really needs to be super flexible and allow you to do whatever you want. OK, so how do we do this? So one of the issues is that we found that the inbox widgets, they're simply not flexible enough, right? They were designed for a certain type of UI. It's very similar to that web example I showed. Like there was an assumption that that is the way a button looks, and it doesn't hold. So one way of doing it, you could add a whole bunch of parameterization on all widgets and just allow people to customize them. We took a different and in some way more extreme approach, which is we don't think we should differentiate between system widgets and app widgets. It's all just widgets again, right? It's all just code. So there's no such thing as a system widget in the Flutter framework. It's all just source code. When you get the framework, everything you see in green is sitting there in our GitHub repo. It's just many, many layers of classes. At the top, you get the system widgets you would expect. So there is a material raised button or a Cupertino slider for iOS. And they will look and feel just like the ones you're used to, and we'll get back to that. But if you try and peel below them, you will see they all depend and compose some smaller widgets with smaller behavior, which again depends on a rendering layer that's again all source code, which again depends on our animation framework, which is all source code, our painting framework, even things like gesture recognition when you swipe on the screen or whatever you do. It's all just source code sitting in the framework. Then all the way at the bottom, at some point you need to bottom out, right? And we bottom out in an engine that is super efficient at rendering, and we'll get back to how that works a little bit later. But the main benefit here is, because it's all a framework and it's all source, you can go see it. You can customize the heck out of it. If you don't like our button and you don't like the customization option we gave you, just copy our button and write your own button. Once you're done with that, create your company button and share it with your friends, right? Just do whatever you want. It's all just source code. Let's do a small demo here. There's only so much I can do in a few minutes, so this will be a fairly simple example. But the example is, OK, that's running. So I had a customer who wanted to do like a round button like this, right? And most buttons, you see those square, right? So what I did is we want to try and define a circular button class. And this is my main app here. It only has, I created the stub class already for a circular button, and there's a text here. So our goal now is to complete the source code for a circular button. We're giving it 2 arguments, the text widget that goes inside it, and just an event handler that makes sure that when you click it, it prints to the console. So we will go to declaration on this, and you can see right now this is the whole source code for circular button. It's these 10 lines. And it does nothing but take in arguments. And then it returns that widget you pass to it centered, which is why the button right now is in the center. So our goal now is to sort of extend this into a circular button. The thing you do is you compose. So we are going to compose something around this. So I'm going to refactor this by wrapping it with a new widget. I know the starting place here is a button, so I'll use a raised button. And we will save this, and there's a button already. It doesn't quite look like a button. I can't click it right now. It doesn't really do anything. And that's probably related to this warning here saying, I didn't pass in the unpressed handler. We didn't pass on the argument here, so let's do that. Unpressed should be unpressed. We'll save again. And now it's all wired up, and you can see it's printing in my console. It doesn't look very circular, though. So let's look at the declaration. Now we're in the Flutter framework. But it looks no different from the app code we just had. This is just a class that extends another class. And if I go all the way up, I will find a stateful widget at some point. This is, again, just taking in arguments, just like my circular button. And somewhere here, there should be a build method that actually builds it. This is a fairly complicated widget, so there's many more lines of code, but they look just like my lines of code. Let's look at the arguments. It takes in a bunch of colors, and it looks like it also takes in a shape. And a shape has a shape border. That sounds promising. So we will go here. We will specify a shape. I don't quite know what the type of that is, so let's see what a shape border looks like. And let's search for the word circle. It looks like I can pass it a circle border. I'm going to be opportunistic and just grab this here and go back and say the shape should be a circle border, and let's try and save that. OK, it's certainly a circle now, but it looks like the size is slightly off. We also have UI inspection tools here that are a little bit more simple, but I can turn on debug painting, which shows me all the constraints that are being applied to each and every widget. And it looks like from these constraints, we're constraining the size of the circle to the height. So I could go ahead and I could reconfigure those constraints. But just in interest of time, I'll just compose this in another widget, which will tell it what size to be. So we will go here. We will refactor, wrap this with a new widget. Sized box is the thing that specifies sizes. We will set the height to 120 and save, and it should be bigger. And it's still a button. So now we just have to fix the border. So we will look at circle border once again. Let's try and see what arguments I can pass here. Oops, I can pass a side, and a side can be a border side. And what arguments do I have? I'm lucky, I've got a color. Color start blue, I'll save that. And it's blue. It's not quite thick enough, so let's see what other arguments. We have a width, and we'll make it 2 and save it. And I want it slightly bigger, so I'll make it 4. There you go. We just built a custom widget. Of course, I know these APIs a little bit, so there's some amount of cheating here. But you could imagine you could go on a similar expedition like I did. It just took me about half an hour when I tried it the first time, because you do have to go and read all those APIs and understand what's going on. But the main message is there's no difference between our widgets and your widgets. They're all just composing these base behaviors. And my challenge to you is just to go look at our APIs and hack the heck out of them and try and build whatever clever widgets you can come up with. All right, moving on. Here is a less naive example. This is actually from a Danish company called Reflectly. I don't know if they're here today, because I think they're in Copenhagen, but they often are. Anywho, they have this highly custom app. Everything is custom here. The fonts are custom. The animations are custom. Each and every control that's on here is a custom control they wrote. And I think it's a super beautiful design, and it conveys this very calm environment that they wanted to have. They actually built this first using a alternative framework, a different framework. They were not quite getting the performance they wanted, so they rewrote this in Flutter with a very small team, just about a handful of people over 2 months. They rewrote the whole thing and launched it on both Android and iOS to hundreds of thousands of customers and got great reviews from the beginning. So I think it's a great validation of the type of design you can create once you are no longer bounded by the system widgets. All right. So We have a different way of coding. We have a different way of doing widgets. But there's something we don't want different. And that's the fact that it needs to feel like native. We cannot compromise here, because then the whole thing is just a moot point. We spend a lot of time studying the mechanics and physics of widgets. Most people don't notice this, but if you take out your phones and open the email app and you try and overscroll, they overscroll in different ways, right? So on Android, you get this blue halo telling you that there are no more emails. But if you do the same thing on iOS, you get this weird bouncy effect, right? And some people notice these things, or at least they know that they notice them. But I bet everybody actually does notice them if they're different. So if you try and ship the Android behavior on iOS, you get in trouble. It doesn't feel like you're on iOS anymore. So these things you should not customize, because there's certain things users just expect. We also spend a lot of time making sure we have fidelity in terms of the actual look. This is a montage showing on the, I actually don't recall which is which. One of the two sides is the actual iOS settings app. The other one is a Flutter version we implemented to clone it. And this is a testing tool we have where we can drag from side to side and look at the two. And I don't think it's actually pixel perfect, but it's close enough that people seem to not be able to tell the difference. We've done a bunch of so-called cafe studies where we walk out with an app and we ask people to guess which one of the two it is. And it usually goes, they can't tell the difference. We've especially worked a whole lot with the material team, again, because they're so close to us. And they're actually one of our biggest customers. Because it turns out, I don't know if you've seen the recent pivoting for material, but what they did at I/O this year is that they launched a huge update to the material framework in recognition that modern apps need to break free from the initial assumptions of material and do things that are a lot more creative, a lot more varied across each app, so all apps don't end up looking the same way. And the material team actually uses Flutter when they prototype and build their widgets, because they get that same developer experience that I showed before for building custom widgets. So they're one of our big partners. And we, of course, as a result of that, have fantastic support for material. When they launched the new material update at I/O in May, all the widgets were in Flutter from day one, and they had to come out with sort of a jagged release cadence across the other platforms. So that's something we're super, super happy about. Okay, I promised I would get back to the bottom, because this is how we get speed. The bottom is written in C++, but we've not written very much of this. We reuse Skia, which is a super well-proven rendering engine using its OpenGL backend. This is the same thing Android uses, for example. We reused some learnings for text rendering from the Chrome team. And then we use the Dart language, which is a language you may or may not know. It doesn't have a ton of adoption. But it does have some really, really, really cool technology. So what we do with Dart is, as I mentioned before, when you're in development mode, we run in that virtual machine. Virtual machines are great at updating code. They're also really fast once they're warm. So if you stick a virtual machine on a server, you warm it up, you give it a few hits, and it becomes super fast. The problem is on a mobile app, you don't want to warm up your app, because that would be the user warming up your app. They're going to clip your app icon, and they want an instant rendering of the first frame. And they will tell if the first frame is slower than the next 17. So when you do a release build of a Flutter app, we build a whole new compilation pipeline for Dart, where we ahead of time compile all the codes to native machine code. Because remember, it's not only your app code that's written in Dart, it's the whole framework. It's our rendering, our gestures, everything. So by compiling all of that to native machine code, we get really, really close to the processor and get super fast startup and execution speed. And we either further fine-tuned things like the garbage collector. It turns out when you do animations, for example, there are lots of objects being allocated. For each frame for an animation, there's 60 frames every second, tons of objects being allocated. Many of them only live that single frame. They get thrown away again. So we actually tweak the whole garbage collector to optimize for scenarios like this to get much better speed. Here's an example of just how fast we can get. This is from one of our partners. They do 2D animation tools. This is a so-called skeletal mesh animation. So there's this skeleton behind this robot, and we're meshing or layering onto it the clothing and whatnot. And And this is all rendered on device using the Flutter framework. And it's actually, it's hard to see up here, but when you run the app on your phone, it responds to touch. So there's nothing pre-rendered here. And even further, you can see there's some text and stuff on top of the animation. That's just some more Flutter widgets. There's even a toggle control that's a Flutter widget. And you may be able to see that you can see the robot through that control. So we have a translucent control being stacked on top of a 2D rendering that's being rendered on device, and this is happening at 60 frames a second. This, I believe, is only possible because of the work we've done to get all the way to native ARM machine code and a super fine-tuned GC system. Let's try and step back a bit, though, and sort of compare what's happening here to things you may know. This is a typical architecture for native SDKs. I think this is Android. All the way at the top is your app code. It sits on top of all these layers, all the way down through the stack, right? There's the whole API framework. There is the whole Android runtime. There's all the native libraries that come with that. There's an operating system at the bottom. Many layers. Then we went through a period where we tried to apply the web to mobile, where the idea was it's not so flexible with those widgets in that deeply layered hierarchy. Let's try and throw a web view into the mix. Web view is so super awesome for doing creative rendering, right? Like there's tons of great websites. So it's actually a pretty good idea to try and use the flexibility of the web to create these super flexible UIs. The problem is speed again. Whenever your code up there running in that JavaScript VM needs to communicate with the OS, they're doing it via interrupting from the interpreted JavaScript all the way down to the machine code. And they're doing this frame by frame. It's just not very fast. So it's super flexible, but not that fast. So the reaction, of course, to this was to try and separate the two. So things like React Native, they use native widgets to get great performance in the widgets and just keep the logic in non-native. But then you get this bridging sideways, right, where your app logic that's driving the UI is non-native and is talking to native widgets. And depending on how you use that, that can be fast or not so fast. It depends on how you drive the UI, but you can certainly hit certain types of limitations. But again, it's great because you get this really expressive and fast UI. It turns out there's actually a super well-known fourth option, which is highly portable, has super fast speed, and supports really creative layouts, and it's gaming engines. Right? And why am I talking about gaming engines? I'm talking about it because as an architecture, it's actually a well-known thing. And the thing is, if I go back and forward, this is Flutter, and this is gaming engines, and this is Flutter, and this is gaming engines. And it's the same, right, as an architecture. But they're entirely different products, of course, right? And I would not recommend writing games using Flutter because we didn't optimize for that. But the architecture is the same. We control all the rendering on the screen. We go directly to Skia to push out pixels. It's all GPU optimized, and it's extremely portable because the touch points between us and the OS are super slim. We just need Skia and text and Dart, right? And it's really expressive because you can just do whatever you want on that canvas. So the interesting thing is, this actually has been done. It only took about a month or so after launching Flutter. We told our customers this is not a gaming platform, and they wrote a gaming framework because that's what people do in open source. They're amazing, right? And then someone decided to create like a Candy Crush thing, and someone decided to create that dinosaur thing from Chrome, right? Because that's how flexible the technology is. Someone also decided like I should try and run my Flutter app on a Wear Watch, right? And you can do that because it's just embedding the same thing on the host OS. There was a little bit of work, of course, because this is a round screen. So there was another 20 lines of code or so to actually make the UI round. And then someone decided, like, why should I limit myself to mobile devices? So there was this little embedding project. So what I have here is Xcode and about 20 lines of Swift here to basically create a window frame. And when I compile this, it pulls in the Flutter engine and some precompiled Dart code and all the source code for all the widgets. And here's a Flutter app running now natively on macOS. And there was a little bit of work here. It's still counting. I can use my mouse now instead of my finger, and I can type. And I can even open like system dialogues. I should make it clear here. What I'm showing you here is not the Flutter product, right? The Flutter product is a great framework for building mobile apps for Android and iOS, period, right? But Flutter, the technology, is a very, very general, very, very flexible thing, and it's being pushed in all kinds of directions. And this, to me, is where it becomes really interesting, because there's one thing I know that is a constant in technology, and that's change. And I imagine this will go in new places in the future. All right, let's just close out with just a few examples of who's actually using this. I will give you one internal example. This is from the AdWords team. They have these apps to use for managing app campaigns. They had an existing native Android app, and they needed an iOS app. They didn't have any iOS skilled developers on the team, so they decided to try out and write the iOS app in Flutter. That went well, so they decided, why should we keep the Android app when we can just recompile the iOS app for Android? And they can do that again because they're using 100% material design on both platforms. So they are no longer maintaining their Android app and are just single sourcing everything now from their Flutter app. And they have several million customers using this. Another example is Alibaba, one of the huge tech giants out of China. They took a different tact. They wanted something more gradual. So they had this existing Android and iOS app, and they wanted some new flows in the app. I don't exactly know what these do, but I think it's some shopping thing. They wanted just to build those UIs using Flutter. So they just took their existing apps and added in a Flutter view as any other view in the app, and they render some subset of the screens using Flutter. And this has also been deployed to millions of devices. And they're now gradually in a process where they extend out what part of the app that's written in Flutter versus what is native. There's a lot of momentum. I don't want to do marketing here, so you can look at that later. I do want to close with just the last slide. There are 4 main ways you can play with Flutter today. You can just create an app from scratch, Flutter create, your name. You can compile that for both Android or iOS, or you can go and look at those crazy things on the internet for running in other places. You can prototype new ideas. This is what the material team does, so this is how they build their widgets. You could do what the AdWords team did, which is to bring your app to the other platform. And if at some point you choose, you can use it for both platforms. Or you can use it just for part of your app and gradually, over time, extend things out. In summary, we have 3 core pillars. High-speed velocity, using things like UI inspection and hot reloads. A super expressive framework where everything is a widget, everything is at your disposal, and you can build these highly expressive designs. And we've really focused on native in the sense that we compile all the way down to native code, and we give you the native feel that your customers expect. And it's a highly different architecture, so if nothing else, I invite you to take a look for curiosity's sake and experiment with it. Thank you so much.
Wonderful. Do you want to come over? Thank you, Michael. Superb. I think we've probably just got just a couple of minutes for questions. Do you want to come and take a perch on the rocking chair? Here, take a seat. Right. Careful, it will buck you off the stage. So that's fascinating to me because I've seen what feels like different attempts to try and normalize this development experience in the past, but this looks just a little bit different to me. It looks like it's gone a little bit further. And there's a bit of a theme at the conference of the future of UI, the future of front end, and what have you. And it seems like one of the themes we're seeing is huge diversity still, of course, and like many devices and many OSs. I just caught when I was backstage you mentioned like having Mac OS as a target as well. Could we see this having other build targets beyond that? I mean, could it reach out to things like Apple TV or smart TVs, or could it? Where are the limits of this? So again, Flutter the product right now in here is focused on a great experience for Android and iOS. Right? We're not done with that mission from a product point of view. It takes a lot of polish to actually create a 1.0 product, and we're not there yet. So from a product point of view, our main focus is exclusively on those 2 platforms. But technology changes, so the platform certainly is flexible. So we will see what the future brings. Interesting. Okay, I mean, even within, you just take actually even increasingly in iOS as well now, but I often think of the diversity that just exists just within Android.
Yes.
You know, the range of screens and devices and powers and all of those kind of things. I think one of the expressions you used was you never wanted to say no to designers. And as someone who's worked at an agency, you know, for a long time in my past, I often had to do that. So I love that as a goal. Do you think, I mean, some of the things you were showing there were incredible. Do you think that you are able to, you've reached that goal of saying we can, you know, avoid saying no to designers, even if we're having to deliver out to this huge range of, for instance, Android devices that have different screens and those kind of things?
I think in terms of expressivity, I think it's flexible enough that you can create most things.
Right.
I think one of the gaps we have, though, we've seen both internally and externally, is in designer-developer collaboration. Developers usually have a fairly easy time getting used to this way of describing UI, but it's quite foreign to designers because it doesn't look like the tools they're used to.
Right, right.
We've had some designers internally that have actually learned this and can build prototypes. But I think we need to invest more in tooling to help bridge that gap. That is not an area we have much support for yet, but I think that is an area we'll have to spend more time on.
Yeah, that seems to make sense. I also love the fact that you're talking about a multi-platform UI, but I think a lot of that is rooted in the platforms that you can develop on as well. You know, so seeing the fact that you don't have to just use the Android IDE, you can use Visual Studio Code and things like that. I think that will help to reach an ever-broadening audience of developers.
We've also had some developers ask us, like, because again, those experimental embeddings exist. Like, why do you need an emulator? You could just run the app during development on macOS itself. It'd be a much faster experience, right? So there's certainly a bunch of different interesting angles there we will look at after we're done with the core product first.
Yeah, it's really exciting to see. I'd love to chat more, but we're out of time. So for now, join me in thanking Michael Thomsen, everyone.
Thank you.
Thank you, Michael.
Thank you.
Thanks.